All right, this is very exciting. This is the very last section of Math 53. So we are going to talk about functions. Okay, so a lot goes with functions. So the first thing we're going to do before we even talk about what a function is, and we have functions are very useful. All of the lines that we just graphed, or most of them, have been functions. Specifically, if we think of the one in the story problem with the pool toys, that was a linear function. Functions are important because you can do a lot more with them, and they represent real life a lot more than equations that are not functions. So that's why functions are very important. So again, before we get into functions, though, we're going to talk about a relation. So what is a relation? A relation is any set of ordered pairs. Any set of ordered pairs at all is considered a relation. So I have an example here. Here's a relation. It has a set of 4 ordered pairs. It can have 1 ordered pair. It can have 5,382 ordered pairs. Mine has just 4 because I'm lazy. So this is a relation, any set of ordered pair. Now, every relation has what we call a domain and a range. So whenever from now on you see capital D, it's going to stand for domain. And the domain is simply the set of all of the x's of all of the points in your relation. So in this case, my domain, and when I list them, I'm always going to list them in order from smallest to biggest. So if I look at just all of my x's and all of my points, that represents my domain. In order, it would be -6, -2, 1, and 5. That is the domain of that relation. Domain. Domains become very important in your next class, Math 113. The R stands for range. Every relation also has a range, and probably no surprise, the range is the set of all of the y's. So in our case up there, if I look at all of the y's and list them in order, I'm seeing -1, then I'm seeing 0, and then I'm seeing 3. Now notice 3 actually happens twice, but that's okay. We're only going to list it once. So the range of that relation, R, that I have as an example, is the set of numbers -1, 0, and 3. So there's domain and range. Domain is the x's, range is the y's. So now let's talk about a function. A function is a special type of a relation. A function is a relation where every element of the domain might help if you could see that. I'm sorry. Where every element of the domain is paired with exactly one element of the range. So every x is paired with exactly one y. Every x is paired with exactly one y. So think of it this way. If I have a function, it means that none of the domain can repeat. Remember in this guy up here, my relation I had here, I had a range that repeated. This range repeated. That's okay. It's nothing in the domain can repeat. So this relation that I have here is actually also a function. It's a function because none of the domain repeated itself. Range, they can all be the same number. It doesn't matter. None of the domain repeats itself. That's what this means. Now, We look at relations in many different ways. One way to look at a relation is by looking at a picture or a graph. And the question becomes, how do I tell by looking at the graph if the relation is a function or not? How can I tell by looking at a graph or a picture if my relation, my set of ordered pairs that I'm about to graph, is a function? Well, you use something called the vertical line test. And here's how the vertical line test goes. Let's say I have this graph right here. I just drew a line. What the vertical line test says is that if I draw millions and billions of vertical lines, remember vertical means up and down, on this graph, will any one of those vertical lines hit the picture, in this case of a line, more than once? Is there any way that I can draw a vertical line that will hit this line more than once? No, every vertical line hits it only once. What that means is, yes, it is a function. That's how the vertical line test goes. Now, let's look at a graph maybe that looks like this. There's a picture. It's a relation. It's a set of ordered pairs. The question is it a function? Does it pass the vertical line test? Well, if I draw that vertical line, how many places does that vertical line hit this graph? It hits it twice, doesn't it? And in fact, almost every vertical line I will draw will hit it more than once. If any vertical line hits the graph that you're looking at more than once, it is not a function. Now let's see why that makes sense. Let's say if I look at this vertical line right here, do you see where it hits the graph here? Let's say it kind of looks like it hits it at 2, 2, and it also hits it down here at 2, negative 2. So there are 2 points on that graph that look like that. Well, what's repeating? The x's is repeating. Remember we talked about the x's can't repeat if we are looking at a function. How about this graph right here? Is that a function? Does it pass the vertical line test? Yes, it does. Yes, a function. And in fact, every single line will be a function, except for one line or one type of line. And that type of line is a vertical line. If I have a vertical line, don't write this in your notes, but just to show you here. If I have a vertical line, let's say this vertical line, does it pass the vertical line test? No, because if I draw a vertical line right there, it hits it more than once. So a vertical line is not a function, but every other line actually is. So now that we have these things called functions, there's a special way that we represent them. We represent them by using f of x. So what this means, this notation, it means that y is a function of x. So if we see this notation f of x, don't let it confuse you. So for example, if I had f of x equals 2x plus 3, all that means is my function's name is f, and this is the variable that is used in the function. That's all that means. If I have g of a equals 6a squared minus 1, that's a function. Its name is g, and the variable used is an a. So that's all it means. But we can only write functions in this function notation. Okay, so where does this function notation come in handy? Well, it comes in handy if we have a function like this. Notice it's in function notation. And if we want to write this function at specific values. So look, it says f of x equals 3x squared minus 2x. And I want to know, what is f of negative 2? All that means is you're going to take the negative 2 and you're going to plug in negative 2 wherever you see an x. So f of negative 2 would simply be 3 times negative 2 squared minus 2 times negative 2. You just plug and chug. Well, we'd have to do our exponents first, so that would be 3 times 4, and then negative 2 times negative 2 is plus 4, which would be 12 plus 4, which would be 16. So f of negative 2 is 16. So we can find the function at a specific value. How about f of 3? Well, how would I find f of 3? I would simply take the 3 and I'd plug it wherever I saw an x. So it would be 3 times 3 squared minus 2 times 3. Do your exponents first, so 3 times 9 minus 6, which is 27 minus 6, which is 21. Now you'll learn a lot more about function notation in other classes, but for right now, this is all you need to know. How would I find f of a squared? Well, the same way. I would just go up into my function. Wherever I see an a, I'm going to put a squared. So it would be 3 times a squared squared minus 2 times a squared. Do your exponents first. What's a squared squared? Well, that's a to the 4th, so it would be 3a to the 4th minus 2a squared. You can't combine those. They're not like terms, so don't be doing anything wonky there. That's as far as it goes. F of negative b, same thing. Wherever I see an x, I'm going to put negative b. Now watch your signs. So negative b squared would be positive b squared, because that's like having a negative 1 there. So it'd be 3b squared, and then a negative here times a negative here would be plus 2b. And there you go. All right, so I think I'm just going to keep going with this video. Even though we're at almost 13 minutes, it's going to be a rather long video, but that's our last one. So let's look at number 2. Is this a function of x? So in other words, is this a function? Well, first of all, hopefully you recognize this is a line in slope-intercept form, and I just told you that any line is a function unless it's vertical, which is this not. But it says check a table of values. So what we're going to do is we're going to check x. Now it's not going to be xy, it's going to be xg of x, because in the y's place is a g of x. So in other words, if we start plugging values in, so if we plug in 0, if we plug in a 0 there, you can see we get 5. If we plug in a 1, negative 2 times 1 is negative 2 plus 5 is 3. If I plug in a negative 1, that's going to give me 7. If I plug in a 2, that's going to give me 1. So the key is there any x that I could plug in that would give me the same y? In other words, can the x repeat and give me the same y? I hope you see that no, every x that I plug in is going to give me exactly one y. So since every x gives me exactly one y, that means that yes, we are talking about a function. How about 3? Is this a function? Well, think of this. What does this graph look like? This is a vertical line. And what did we say about a vertical line? A vertical line is not a function. And in fact, remember when I taught you how to graph? Remember I said since this is x equals negative 3, remember how we put negative 3's all down the x column? Notice how the domain repeats. There's another proof that no, that is not a function. How about number 4? Is this a function? Well, what do I look at? I have to look at the domain. Remember? Does any of the domain repeat? Are any of those values used more than once? No, they are not. Since none of the domain repeats, yes, that is a function. Okay, so the last thing we're going to talk about is a little bit more about domain and range here. So it says find the domain and the range. And actually, we're not going to find the range for all of them. We're only going to find the range for a couple. So first of all, this is a line. Remember, what is the domain? The domain is all of the x's. So the key is, are there any x's that I can't plug in there? Can I plug in 5? Can I plug in -8? Can I plug in 5,382? I can plug in any real number for x. So that means that the domain is all real numbers. And in fact, I will tell you that the range is also all real numbers for almost every single line, except for our 2 special types of lines. Your domain and your range is all real numbers for almost every single line. Well, let's look at B. For B, we're only going to look at the domain. So now, here's the deal. Whenever you have a function that is a fraction, and that fraction has a variable in the denominator, you have to go back to very basic math that you know that you cannot have a 0 in the denominator. That is illegal. So if I look at this, so what is the one value that would make this whole denominator equal 0? Well, do you see that if x was -5, this denominator would be 0? Can it be anything else? It can be absolutely anything else. It can be 0 because 0 plus 5 is 5. It can be 10. It can be -8. X can be anything else. It just can't be -5. So we would write it's going to be all real numbers. So all real numbers except -5. That's the one value that my x can't equal. So that is going to be your domain there. And we're not going to find the range for that one. All right, now we can also do this by looking at a picture. Let's say I give you this picture right here and I ask you for the domain and the range. Well, what did I just tell you? As long as you have a line and it's not vertical or horizontal, those 2 special types of lines, then your domain is all real numbers and your range is all real numbers, as long as it's a line. Okay, let's do one that's a little trickier. Let's say I have this picture right here. Doesn't matter what the equation is. It doesn't matter. Let's talk about the domain and the range. So remember, the domain is the set of x's. All of the x's on the graph are being used, because remember, this goes down on and on forever. It keeps going. So this x out here is going to be used. Now the point may be way down here, but that x is going to be used, as is that x, that x. Our domain is going to be all real numbers. Our range is going to be something different. Now, look at our range. Now remember, your range is your y's. So all of these y's are being used, right? because this point right here is what? I don't know, it's 3, -4 or something, 6, -8. So all of these y's down here are going to be used as well. They're going to be used over here too. But like, what about this y right here? But what about y is 10? Or I think that's an 8. Is that going to be used? Is there any point on this graph where the y is going to be equal to 8? No. And in fact, what's the highest y that's going to be used? The highest y that's going to be used is this point right here, which is 1, 2, 3, 4, 5, 6. That's the highest y that's going to be used. Nothing above that. So that means that our range is all real numbers less than or equal to 6. That's the highest y that's going to be used. Now that's going to take some practice, this domain and range stuff. So you'll have some worksheets to help you practice, don't worry. But hopefully that helps you a little bit. And there's the end of your notes for Math 53.